Welcome learners. The objective of this video lecture is to derive Newton's divided difference formula, discuss its properties and an example. Introduction to unequal interpolation. If the independent variable arguments lie at equal intervals, we use Newton's forward formula at the beginning of the arguments. At the end of the arguments, Newton's backward formula if the arguments are at equal intervals only. However, arguments often occur at unequal intervals. In these situations, for unequal intervals, we utilize two formulae for interpolating the given values. First one is Newton's divided difference formula, NDDF, and Lagrange's interpolation formula. Let us look at divided differences. The definition of divided differences. Divided differences are the ratio of the differences between the entries and the corresponding differences between the arguments. Here we take the difference of entries, that is y values in the numerator, and the corresponding differences from x values in the denominator. Let y is equal to f of x, where arguments are x0, x1, x2, and so on xn. Entries y values are y0, y1, y2, yn. The first order divided differences is given by f of x0, x1 in closed brackets. This is divided differences of x0, x1 is equal to f of x1 minus f of x0 divided by x1 minus x0. In terms of entries, y1 minus y0. In terms of arguments, x1 minus x0. This is the first order divided differences. The second order divided differences is given by f of x0, x1, x2 in closed bracket, f of x1, x2, x1, x2 minus f of x0, x1, x0, x1 divided by x2 minus x0, x2 minus x0. So, the third order difference is f of x0, x1, x2, x3 in closed brackets is equal to f of x1, x2, x3, x1, x2, x3 minus f of x0, x1, x2 divided by x3 minus x0. Similarly, the nth order general divided difference is given by f of x0, x1, so on xn is equal to f of x1, x2, so on xn minus f of x1, x2, so on xn minus 1. Here 2 x2, x1, x3, x2. Like that, xn minus 2 divided by xn minus x0. These are the definitions of first and second, third, and higher order divided differences. This is the divided difference table, construction of divided difference table. Here x values are the arguments and y values are entries. First order divided difference, f of x0, x1, so on. This is second order divided difference. This is third order divided difference. The denominator is the difference between the last and first arguments in that subset. Properties of divided differences are: the divided difference of a constant is 0. Linearity property, the operator is linear like Newton forward operator. Delta A P of x plus B of Qx is equal to A delta P of x. Here the delta denotes divided difference. A divided difference P of x plus B divided difference P of x. The divided differences are symmetric functions of their arguments. That means f of x0, x1 is equal to f of x1, x0. polynomial degree, the nth order divided difference of a polynomial of the degree n is constant, and the n plus first term, first order is 0. Like fundamental theorem on finite differences. Equi-spaced relation. The interval, for interval h, f of x0, x1, so on, xn is given by divided difference power n y0 divided by n factorial into h power n. Let us state the divided difference. Statement of divided difference formula. This is called NDDF, Newton divided difference formula. Given n plus 1 points, x0, y0, so on, xn, yn, the value of y is given by f of x is equal to f of x0 plus x minus x0 into f of x0, x1 first divided difference plus x minus x0 into x minus x1 into f of x0, x1, x2 second divided difference, so on, x minus x0, x minus x1, so on, xn minus 1 into f of x0, x1, so on, xn. Here we need to write just below just one order difference. For 0, x1, for 1, x2, for n minus 1, xn divided differences. The assumptions are f of x is an nth degree polynomial. Arguments may be at equal or unequal intervals, and the target x can be anywhere within the range. It may be at the beginning, in the middle, or at the end of the given arguments values. Proof of NDDF. From the definition of the first order divided differences, f of x comma x1 is equal to f of x minus f of x0 by x minus x0. We can rearrange this as x minus x0 multiplies here, and f of x comes into left hand side. By multiplying with minus 1 on both sides, we get this f of x is equal to f of x0 plus x minus x0 into f of x comma x1. Let it be the equation 1. From the second order difference, f of x comma x0 comma x1 is given by f of x comma x0 minus f of x0 comma x1 divided by x minus x1. Rearranging, f of x comma x0 is equal to f of x0 comma x1 plus x minus x1 into f of x comma x0 comma x1. Let it be the equation 2. Substitute this second equation in first equation. F of x can be written as f of x0 plus x minus x0 into f of x0 x1 plus x minus x1 into f of x comma x0 comma x1, multiplying with x minus x0 into the inner terms. We get f of x is equal to f of x0 x minus x0 into f of x0 comma x1 plus x minus x0 into x minus x1 into f of x comma x0 comma x2 be the third equation. Repeating this for higher orders, we get f of x is equal to f of x0 plus x minus x0, f of x0 x1, so on. The last term comes. As the n plus first difference is 0 for an nth degree polynomial, the last term vanishes. Let us understand this with a numerical example. Find f of 2 given the following points. Here argument values are 0, 1, 2. 2 will be here. These are not the equally spaced arguments, equidistant arguments. Here the difference is 1 and here the difference is 3. First order differences, f of x0 comma x1 is equal to 3 minus 2 y1 minus y0 divided by x1 minus x0 1. Similarly, f of x1 x2 is equal to 14 minus 3 divided by 4 minus 1. This is equal to 3.67 approximately. The second order differences are f of x0, x1, x2 is 3.67 minus 1 divided by 4 minus 0. This is 0.6675. Applying Newton divided difference formula, f of 2 is equal to 5.335. And in SV University semester end examination, fourth semester end examination conducted during April 2025, problem 12a is find the value of f of 8 using Newton's divided difference formula. Here the x values are 4, 5, 7, 10, 11, 13. These are not equidistant values. H is not same for all values. F of x is the values, and construct a divided difference table, x arguments and f of x arguments. These are the first order divided differences, second order divided differences, third order divided differences, fourth order differences. These become 0. So we substitute the divided differences and x values, x minus x naught, x minus x1 values. We apply the formula f of x is equal to f of x naught, x minus x naught, f of x naught, x1, so on, up to x3 values only. x3 values only. F of 8 is equal to 48, and the last value is this one value. So f of x0, x1, x2, x3 is 1 here, 1 here. So approximately this is equal to 448. Thank you.